Hi, Earth Science. I just want to take some time to go over air masses and fronts. We had a lot of people out on Thursday, Friday, wrestling, sicknesses, all sorts of things. So you're going to need this information to work on the assignments we have coming up that rely heavily on your knowledge of air masses and fronts. So there's a document on Google Classroom that captures the notes in case you missed it, because we had people who were here, so we went through and talked about the notes, and then we had people who were absent, so you wouldn't have gotten these notes. So I just screenshotted what the notes are. We'll go through them real quick. So an air mass is a large body of air in the troposphere, and it has similar characteristics of both pressure and moisture. And these start because you get stagnant air over one area for a long time, so it takes on the characteristics of that area. So let me explain. If it's hanging out over the ocean for a long time, it's going to be wet air. If it's hanging out over land for a long time, it's going to be pretty dry air. If it's hanging out in a high latitude place, like up by a pole, or way up in the Arctic, it's going to be cold air. If it's hanging out in a place that's warm, say the tropics, it's going to be warm air. So this is how this plays out. So it's pretty easy to keep track of once you got the hang of it. So here's our types of air masses. We have tropical ones, and these originate in low latitudes, the tropics, and they're going to have high temperatures, as you might expect. Polar, low temperatures. The Arctic, very cold, very cold. Equatorial, very hot and humid. Continental originates over land, it's dry, and maritime originates over water, it's wet. So there's two things we got to keep track of here, guys. It's the moisture content of the air, whether it's dry or wet, and then whether it's warm or cold. So looking ahead here, in your notes, you have places to put symbols. Now, it does matter a lot that you capitalize the correct letters here. So these first ones, the C's and the M's, these are going to be lowercase, and then the P's and the T's are going to be capitalized. Continental polar, CP, these are going to originate over land, so they're dry. They originate in higher latitudes, so they're going to be cold. Maritime tropical, over water, that's maritime. Anything with the word mara in it usually refers to something having to do with the sea, so you guys can think of the Seattle Mariners, or Marineland, or anything like that. So mara means over the sea, or associated with the sea. So we have maritime tropical, it's going to be warm and moist. Continental tropical is going to be hot and dry, because again, the continental indicates that it's dry, and then maritime polar, these are going to be cool and moist. So on the next page, it asks you to draw these air masses onto a map. So when you're ready, we'll go ahead and do that. If you need more time to go over the notes with the document, just scroll through the document, pause the video, and then click it when you're ready. But I'm going to keep on moving because I'm excited about this. So the map looks like this, and really what they're asking you to do is to take your pen or your pencil and draw somewhere these air masses would be. So I'll draw one just to show you. Now remember, weather generally moves from west to east across the United States. So I'm going to grab a bubble of air over here, draw it, and I'm going to put an arrow on there just indicating which way it's heading. Great. And because this is over water, I'm going to put the small m there to indicate it's maritime. And it's a higher latitude. This is like Alaska up here. I'm going to go ahead and call it polar, just for fun. Maritime polar. Looks good. I'm going to put one over land, too. I might even put it like way up here. And draw it. Coming down. The far reaches. I'm going to call this, it's over land, so I'm going to put C for continental, and I'm going to call it Arctic. We're going to pretend it came from like way up north, super cold. And then we're going to put, well, I'll make a continental polar one too. I don't want to leave them out of the mix. Coming right over the lake, I bring in some lake effect with it, because that's usually what these things do. You got cold air over warm Great Lakes, and guess what? Mayville, Ripley, Stockton, Jamestown, we're going to get hammered. So here we have continental polar. Okay, enough of the cold stuff. For those of you that like warm, I'm going to put one down here. As you might expect, maritime, it's over the water, yes, but no more of the polar Arctic stuff. We're going to call it tropical. Let's bring warm, wet air over to the Baja Peninsula here, and let's make one start right over Texas. So over land, continental, warm air, tropical. Great. Now guys, here's where these really come into play. We have these big bubbles of air moving across the globe at any given moment. When they start to encounter each other, that's when we have what we call weather fronts. So fronts are the fronts are going to be the boundary between two air masses, and it's going to produce some action as far as weather goes. So let me just grab this guy here, make him all together, and we'll take this guy right here, bring him together. Okay, great. Now if this guy keeps moving this way, come here, you. And this guy keeps moving this way, eventually, look, they're going to bump into each other. So now we have hot air and cold air mixing, and where they meet, we usually call that the front. And we get this from military terms, right? So if there's two groups of soldiers and they got close enough to each other and they start shooting at each other, in military terms we call it the front. So a front is where two of these air masses come together. That's kind of where your notes are going to go next. So on the next page here, it says types of fronts. They give you 3, but we're actually going to cover 4 because there's 4 that you're responsible for. But first, let's just talk about what a front is. So a front where two air masses meet. That's what we just said there. So we got 4 kinds. We have a cold front, a warm front, a stationary front, what we call an occluded front. The map symbols for each of these are going to be as follows. A cold front map symbol is a line with these little triangles on them. A warm front is a line with these little half circles on them. I always remember these because, oops, that wasn't a good half circle. I remember these because cold, sometimes people will describe cold as being biting, like it's biting cold. So I remember these like little teeth. These look like little suns to me, or like setting or rising sun. So yeah, warm front makes sense. A stationary front, you're going to have a map symbol that looks like this. You're going to have triangles on one side, little half circles on the other. Then occluded fronts, you're going to have both of them triangles and half circles, but this time they're going to be on the same side, like that. Great. Now they're going to want you to draw 2 of these from the side profile, which are important. So we're going to talk about cold and warm fronts because those are our 2 most important and ones that you absolutely have to know. I mean, stationary and occluded you should know. I mean, you could probably get by on a Regents without knowing a lot about stationary and occluded, but I wouldn't recommend you heading into an Earth Science Regents without knowing a lot about a cold and a warm front. So let's take a look at those. So when they ask to draw them, what you guys should do here is, on your sheet you have your notes there. You already have a picture there. I'm just going to sort of create my own here. So here's the ground. Now, with a cold front, what you have is you have a mass of cold air. It's usually shaped like this. Move this out of the way. And it's heading this way. And what it's going to do is it's going to push the warm air up into the troposphere, like this. Because cold air is more dense than warm air. Now, warm air doesn't like to get pushed up into the troposphere because that's going to make it cool off. It gets colder as you go up into the troposphere. So what's going to happen is this is going to quickly rise, expand, cool, and condense. And it's going to form a patch of pretty unstable air. You're going to get a whole bunch of precipitation right in front of the front. See it here? Usually it's going to be somewhat violent. So cold fronts are associated with pretty violent storms. So you might have something like this. And then it's over. So these are going to be thunderstorms, sometimes tornadoes, sometimes really intense storms where you have hail. If you guys can go into your mind about a thunderstorm and when you've experienced it before, thunderstorms are usually, they come on, they're real intense, and then they're over. And then once they're over, it usually cools off. Usually before a thunderstorm, it's pretty hot. And then after a thunderstorm, a nice cool air comes in. It gets much more comfortable because this is exactly what happened here. So this is a cold front. Should we note that? Cold front. We name the fronts after the air that's behind it. So here's the front, and the cold air is behind it, so that's why we call this a cold front. Okay, let's do a warm front real quick. Okay, so here we have the ground, and in this case, the warm air is coming this way. Now, warm air is not as dense as cold air, so it will push it out of the way. But it has to rise above it to do so because the cold air is more dense. So what you're going to end up getting here is some wispy clouds here. And then a whole bunch of precipitation in front of it. And this rain will last for several hours. No thunder, no lightning, no storms. Just a bunch of rain, and then eventually the warm front will move in. I'm going to draw the warm front map symbol on the ground in my notes, and I'm going to actually go back and do the same thing for the cold front. So once you're done drawing this, you jump back to this one. Forgot to do it on here. And we're going to draw that here just because we're trying to get the hang of this. So warm front, lots of rain, but no storms, just long periods of rain. A cold front's much quicker rain, more intense storms are coming in. And we'll talk about the stationary and the occluded front on the next video, which won't be as long as this one.